Okay, so on the last video, we looked at just regular inequalities, and that last video should help you with numbers 1 through 5 in your assignment for the week. What we're going to work on now are what are called compound inequalities. These are your inequalities that usually have the word or they'll be and inequalities where they have a variable in the center and then have two inequality signs there. So we're going to talk about how to handle both of these, and this should help you with numbers 6 through 10 on your worksheet. So let's look at this first one. It looks like I have two inequalities in one, and you kind of do. The word or is going to separate them. So I'm going to solve out each one of these for x. And we have two parts to our answer that we're going to look at. So let's look at the left side first. So I'm just going to solve this for x. There's no parentheses, nothing to combine, so I'm ready to start moving things. So I have a minus 6. Remember, you move constant first. So we're going to add 6 to both sides. So we have 3x is greater than or equal to 6. Now I need to get x by itself, so we're going to divide both sides by 3. So we're going to get x, and I don't change my sign because I didn't divide by a negative, I divided by a positive, so it's going to be x is greater than or equal to 2. Bring down my word, or, now let's solve this one out. So we're going to first move the constant, it's a positive 5, so we're going to subtract 5 from both sides. So we get 4x, 5's gone, is less than or equal to negative 8. Then we're going to divide both sides by 4. Again, dividing by a positive, so it's not going to change the sign. And so it's still going to stay less than or equal to. So x is less than or equal to 2. Now, in a compound inequality, both of these are part of my answer. Both x is greater than or equal to 2, or x is less than or equal to negative 2. So how do we do this? Well, we graph both on the graph. Or means this or this could be the answer. So everything gets graphed. So x is greater than or equal to 2. How does that look? Well, is it going to be open or closed? The equal sign tells me it's closed at 2. And greater than, or looking at the inequality pointing to the right, means we're doing above. Less than or equal to negative 2. Again, that equal sign makes it closed at negative 2. My inequality is pointing to the left. It's a less than, so that means I'm shading to the left. And this is your typical OR graph. Your typical OR graph starts at 2 points and then moves out to both sides. And that's it. You're done. Let's try another OR. So on this next one, we have negative 6x plus 3 is less than negative 15. Or, there's that word again, separating the two. 1 minus x is greater than or equal to 5. So on the left side, we are going to move our constant first. So I'm going to subtract 3 from both sides. We get negative 6x is less than negative 18. Now, to solve for x, I need to divide by negative 6. We're dividing by a negative, so cancels out. But what does that do to this? Flips it, makes it a greater than instead of a less than. Negative 18 divided by negative 6 is positive 3. Bring that OR down. Okay, on the right inequality. So first I want to move my constant, so we're going to subtract 1 from both sides. So we have negative x. Don't forget the negative, that's still there. The 1's gone, but we still have negative x is greater than or equal to 4. Okay, can I leave that negative in front of the x? Well, no, because that's like I'm multiplying by a negative 1, correct? So I need to divide both sides by negative 1, which gets rid of that. I divided by a negative, so we flip the inequality, and there you have it. Okay, again, with OR, I graph everything. So I'm going to graph x is greater than 3, or x is less than or equal to negative 4. Both of these need to be graphs because either or could be your answer. So greater than 3. All right, no equal signs. That means it's an open circle at 3. Now, if you'll notice, we only have the even numbers here. So 3 is right here, open circle. Greater than means we shade to the right. Now, at negative 4, this is going to be a closed circle because it has an equal on this side, doesn't it? And it's less than, so we're shading to the left. And that's your answer. Again, we're not doing set notation. This is going to be your answer right here. And then the graph as well. So with ORs, typically they start 2 points and head out. Okay, let's look at one that looks a little different. This is actually an and problem. And I know it's an and problem because while I only have a variable in the center, I have two inequality signs. I have one here as well as here. Essentially what that does is I now have an inequality with three sides. I have the middle, I have the left, and I have the right. My goal is to get the variable by itself in the center. So I want to move everything away from that variable in the center. But what's going to happen here is much like an equation where whatever you do to one side, you have to do to the other. In an inequality that's an and like this, whatever I do to the center, I have to do to both the left and the right sides. For instance, here, to get x by itself, we always move the constant first. So I want to get rid of that minus 4 first. That means I'm going to add 4. But if I do that to the center, I have to do that here as well as here. So negative 16 plus 4. Okay, those are opposite signs. They're going to cancel each other out. So I have negative 12 is less than or equal to 3x. That's gone. Is less than or equal to, whoops, I left out my 4. 2 plus 4, which is 6. So we added 4 to the center, to the left, and to the right. So negative 16 plus 4 gives us negative 12. That canceled that out and left us with just 3x. And that plus 4 was 6. Okay, still trying to get x by itself in the center. That's still my goal. Right now, x is being multiplied by 3, so I need to divide by 3. But what did we just learn? Well, whatever you do to the center, you have to do to the left and to the right. So negative 12 divided by 3 is negative 4. That's going to cancel out and make x. Negative 6 divided by 3 is 2, and we have our answer. Once your x is all by itself. Now, the way this graphs, this is saying x is between these two numbers. See, if you read these symbols, this is saying that x is greater than negative 4, but it's less than 2. So it's between negative 4 and 2. So how do we graph that? Well, let's look and see, first of all, how we're going to do the circles at negative 4 and 2. So for negative 4, I got an equal sign. That means I have a closed circle at negative 4. At 2, I have an equal sign. That means I have a closed circle at 2. And we just said, okay, x is between these two. It's greater than or equal to negative 4, but less than or equal to positive 2. That means we're just shading between these two numbers. So remember how the graph for the OR tended to start at two numbers and head out? A graph for an AND, where you have a variable in the center like this, is typically going to be between two numbers like this. Let's try one more AND. Okay, so on this one we have 1 is less than 4x plus 1 is less than or equal to 13. Okay, we have three sides. We've got left, middle, and right. Remember, our goal is to get x by itself into the center. And we always start by moving the constant first. We're going to move that positive 1. So we're going to subtract 1 to make it go away. If we do that to the center, we have to do that here as well as here. Okay, 1 minus 1, well, that's just 0. Is less than, well, that's gone, so it's just 4x is less than or equal to 12. Is x by itself in the center yet? Nope, so it's being multiplied by 4, so the inverse operation is we divide it by 4. Again, whatever you do to the center, you have to do to the left and the right. 0 divided by anything is 0. Is less than, well, that cancels out, so we're left with just x. Is less than or equal to 12 divided by 4 is 3, and you have your answer. So this time, x is between 0 and 3. So let's do our dots first. At 0, will it be open or closed? Well, there's no equal sign here, so that means at 0, we have an open circle. Whoops, sorry guys. Open circle. At 3, we have the equal sign there, so that's going to be right there, closed circle because of the equal sign, and then x is between those two, so we're shading between. Okay. All right, now you're ready to finish out the worksheet. Do numbers 6 through 10. As always, if you have other questions, let me know. Message me on Teams, message me on Remind, and we'll get it worked out. Good luck.